Hello, Avi. How are you?
I'm doing great. Thanks for having me.
It's a pleasure. Thank you so much for doing this. It's really good to have you on. I got through your lovely book, so I had a really nice time reading that.
Well, I will keep you busy because I'm finishing another book. Hopefully, within a year, it should be out.
Oh, cool. What's it about?
Um, it's about what happened since I wrote my previous book.
Oh, okay. Is there more stuff on Oumuamua?
No, because this object pretty much left our neighborhood. We can't really chase it. We didn't get new information. And as you know, I'm a scientist and I'm guided by evidence. So
Yeah.
cannot get more data about this first encounter, but what we can do is search for other objects like it. And I would like to rendezvous with the next Oumuamua. We already have a dating app
Wow.
in the form of the Vera Rubin Observatory, the large that will have the LSST, the Legacy Survey of Space and Time. And
Hmm.
it's equipped with a camera of 3.2 billion pixels that would monitor the sky and cover
Wow.
the sky every 4 days, and will have much better coverage than the Pan-STARRS telescope that much more. So we are likely to find every few months at least one object like Oumuamua. And then this would serve as a dating app. And then the question is who to date. Most of the time we will swipe to the left. The space mission will cost more than $1 billion. We know that because
Wow.
Osiris-Rex was a mission to land on the asteroid Bennu, and it will bring back material. And that cost 1.1 billion. So that is part of the Galileo project. We're designing a space mission. Once we identify an object as unusual as Oumuamua was, that came from outside the solar system, we will decide to rendezvous with it. It's a very expensive date, but it's worth the money.
Wow.
But then for a cost that is 1,000 times less, just a few $1 million, we can actually collect fragments from another interstellar object that appeared as a meteor back in January 8th, 2014. It's the first interstellar meteor that we discovered with my student, Amir Siraj, based on public data from the US government.
Mhm.
And that meteor landed, the fragments of it, after it disintegrated, they landed within 100 miles off the coast of Papua New Guinea. So we are planning an expedition to scoop the ocean
Cool.
floor. It's very deep. It's 1.7 kilometers, about a mile deep. But we will use a sled with a magnet and try to scoop up fragments from that meteor and figure out the composition. The government just a few months ago confirmed that at the 99.999% confidence, that was a letter from the US Space Command under the Department of Defense to NASA, confirming our finding with my student Amir Siraj, that indeed this object came from outside the solar system based on its velocity. And they also released the light curve of the fireball that was generated when the object disintegrated in the low atmosphere. And that allowed us to calculate that the material strength was tougher than iron in this object, because it
Wow.
disintegrated only in the lower atmosphere, about 18.7 kilometers above sea level. And given its very high speed of 45 kilometers per second, the stress that was exerted on this object was huge. And for it to survive all the way down to the lower atmosphere implies that its material strength was tougher, stronger than iron. And that makes it very interesting, because
Yeah.
not only that it moved at very high speed outside the solar system of about 60 kilometers per second, but also it was tougher than iron. And only 5% of all the space rocks are iron meteorites. So it seems to be peculiar and unusual, rare.
Hmm.
And this is the first interstellar meteor that was discovered. So why would the first one appear so unusual? Maybe it was artificial in origin, and that's what we plan to check. You can just think of New Horizons, the latest spacecraft we sent that will leave the solar system. you can think of it in 1 billion years. Suppose it collided with another planet like Earth, an habitable planet around another star, and landed, and then exploded and fragmented in just above the ocean of that exoplanet. And imagine the astronomers there having an expedition to figure out whether it was a rock or something else. And
Yeah.
And if they ever find the box that we attached to it that carried 30 grams of the ashes of Clyde Tombaugh, the person who discovered Pluto, that would be very embarrassing, because they would say, oh, this civilization who sent this spacecraft was quite aggressive and not very intelligent, because they destroyed all the genetic information about the scientists that they wanted to commemorate. That makes very little sense. You don't want anything to do with them.
Yeah, that could be a possibility. Do you think the fun of it is in theorizing things, that if we found out there actually was aliens, that we'd be like, oh well, we kind of know there's aliens out? Would it take? I know people want to find out the truth, but there's a certain kind of fun in theorizing things. Your imagination can go wild on things.
Oh no, theory is extremely useful because it motivates you to search for things. If you just don't look for things if you don't imagine them. I can give you a number of examples. For example, there will be this data from the Vera Rubin Observatory that will come in, and I asked a person involved in the software development, and I asked him, will you be able to discover objects that came from outside the solar system? And he said, no, we are focused on objects within the solar system. That's what we looked at in the past. So here is an example. If you don't even allow for trajectories that represent objects unbound to the sun, you would never discover them. You have a blind spot. Another example is, when I visited Mexico, we went to Chichen Itza, where the tour guide was telling us that the Mayan culture really regarded astronomers as being at the highest level of society. They were considered the astronomer priests, and that sounded quite lucrative to me, because nowadays astronomers are not really treated with great respect.
No.
They were in the Mayan. So I was wondering, why was it that the Mayan culture, admired astronomers? It turns out that they believed that the position of the planets in the sky and the stars determines the outcome of wars and other historic events. So that's astrology. They basically thought that there is a correlation between where Venus is and the outcome of a war. And if that's the case, then you want to know precisely where planets and stars are in order to decide whether to go out to war. Okay, so that has huge political implications, and that's why astronomers were extremely highly regarded in society. Now, this shows you a mindset that we now know is not the correct way of interpreting, because data, because we know that planets move around. It has nothing to do with the outcome of wars. It's the force of gravity doesn't really affect the outcome of wars. Whether Putin wins or not will not be dictated by what happens to Venus. Okay, so my point is, you can collect a lot of data and just if you don't allow yourself to imagine things that go beyond what is the convention of your society, you will never discover the laws of Newton. Okay, if you have exquisite data on planets and you just believe that planets are important because they affect events here on Earth, then you will never realize that those planets obey the laws of gravity, or the laws of motion. And so that my point is, imagining things is extremely important because it opens your mind to possibilities that go beyond what you thought to be the truth. And the only way for you to discover new things is to allow that imagination to operate. And that's actually the reason that theoretical physicists are getting paid, because most of the time we are using what is known already, using the equations of the standard model of particle physics to predict phenomena that can be tested. And without theorists advocating for doing experiments a lot of things would not have been found. For example, gravitational waves, they were celebrated with a Nobel Prize. And the only reason we went after them is because Einstein's theory of gravity predicts them. And theoretical astrophysicists forecasted that there are events in the universe that we can listen to in gravitational waves. So here is an example of a completely new frontier. We in the past, astronomy was dedicated to collecting light with telescopes, but we never checked for other messengers like gravitational waves. And once LIGO started detecting those, it became a new frontier in astrophysics where we know about events that do not produce any light. When two black holes come together, they just produce ripples in space and time that we detect with a LIGO experiment. So it just shows you that if we can imagine things based on our equations, based on our Einstein's theory of gravity, that leads us to discover new things in the universe. These collisions of black holes would never be known unless we listen to them in gravitational waves.
You were saying in the book that you hypothesized that it could have been a light sail.
So the way I arrived at that suggestion was that to say, okay, there is data that the object was pushed away from the sun by a force that declined inversely with distance squared, and there was no cometary tail. We didn't see any cometary evaporation. There were very tight limits put by the Spitzer Space Telescope on molecules or dust particles that evaporated from the object that can give it its push. And moreover, the force that was acting on it based on the data was smooth. It didn't, there weren't variations. The object didn't change its spin period, the rotation period, as you would expect if the push was driven by evaporation of gas in jets, like the way you see it in comets. So at any event, I said, okay, what else can give it that push? And the only thing that came to my mind was the radiation pressure from the sun, the fact that the sun illuminates this object, and that can push it but for that to be effective, the object had to be very thin. So that led me to suggest maybe it's a very thin object like a sail. And we are currently developing light sails for propulsion. And the reason we do that is because this technology doesn't require for the spacecraft to carry the fuel with it. It can therefore be pushed to very high speeds without carrying any fuel. And that's a possibility. But since then, since I wrote that scientific paper, that by the way was accepted for publication within a few days and received a lot of attention, since then, of course, I wrote my book, but I also came to realize that it may not be necessarily a light sail, because in 2020, in September 2020, that was 3 years after the Oumuamua was discovered, there was another object discovered by the same telescope in Hawaii, Pan-STARRS, which exhibited an excess push away from the sun by reflecting sunlight and no cometary tail. And it was given the name 2020 SO. And the astronomers who discovered it within a few weeks realized that it actually came from Earth. It was a rocket booster from a 1966 launch as part of a lunar lander mission. And so we know that we produced it. We know that it was artificial. We know that this rocket booster had thin walls, and that's why it was pushed by reflecting sunlight. But it was not designed to be a light sail. So it could be just a relic of something else, something that had thin walls. The main point of my proposal was that it could be artificial in origin, because, a rock usually is not that thin. Nature doesn't produce such things. And if it was a comet, we didn't see the evaporation of it. But since then, some mainstream astronomers who worked on rocks for decades argued, well, maybe it's a rock of a type that we've never seen before, like a hydrogen iceberg or a nitrogen iceberg, where we wouldn't see the cometary tail because it's transparent. And there are problems with those suggestions. First of all, we never saw a hydrogen iceberg. We don't know if it's produced by nature. We never saw a nitrogen iceberg. But in the case of hydrogen, it evaporates very quickly. It wouldn't survive the journey in interstellar space. In the case of nitrogen, there is just not enough frozen nitrogen, solid nitrogen on the surface of planets like Pluto. We did the calculation with my students. So So there are challenges, but also we've never seen those things. So you cannot argue with certainty that it
Hmm.
must be natural because it's a rock of a type that was never seen before, because then you would resemble a cave dweller finding a cell phone and saying the cell phone is a rock of a type that I've never seen before. That obviously we need more data, and the only way to find it is to be open-minded.
Hmm. Do you find that a lot of people in your kind of area can be a bit close-minded about that it's extraterrestrial in origin? Because there seems to be a kind of pushback I do find with when you say something's extraterrestrial, people kind of look at you with a bit of like, they're like, oh no, it couldn't be that. I find that weird that we're not kind of open-minded that it could be something outside of us.
Well, first of all, I should say there was a congressman who made a lot of anti-gay statements until he retired from Congress a couple of years ago, and then he confessed that he was gay. And
Yeah.
a lot of people that make those statements deep down may be intrigued by the possibility. Okay, so they
Hmm.
pretend as if they ridicule the subject, they push back on it just when they look around so that they would be liked by other people. But deep down, the reason they make these statements is because they're intrigued by the possibility. The other thing is you have experts who get their reputation um, and all the honors they receive and so forth based on their past knowledge, and they would resist new knowledge. They would
Hmm.
try to interpret any object in the sky as a rock because that's their past knowledge. Okay, so they have but that's contrary to the scientific method of discovering new things based on evidence. They would rather not find evidence so that their past knowledge would represent everything we find. But then when you see anomalies, they should be intrigued. They're not curious. They just want to preserve their status as knowing everything in the sky, and they would argue very strongly that it's a rock of a type that we've never seen before, rather than being open-minded about an alternative. Okay,
Yeah.
and that to me is a deviation from the scientific method, because it's not about you, it's not about your ego, it's about us finding what is out there, and we should not put our ego on the way of discovering new things, because when you claim extraordinary claims require extraordinary evidence and you're not seeking the evidence, you're basically violating the scientific method. When you have anomalies, you should seek extraordinary funding so that you will get the extraordinary evidence. We invested billions of dollars in the search for dark matter, and we went in directions that were dead ends. Where the Large Hadron Collider was looking for the lightest supersymmetric particles. So did anyone ask, do we have extraordinary evidence that the lightest supersymmetric particle is the dark matter before investing those billions of dollars? No, that's part of the scientific process. You look in directions that end up not being real. Okay, and why would people argue against even considering the possibility of artificial objects in space, given the fact that we launch things to space, given the fact that we know that half of the sun-like stars have a planet the size of the Earth, roughly the same separation? Why would that not be considered as completely plausible, more plausible than dark matter being the lightest supersymmetric particle? Okay, so my point is that has to do also with another issue, which I realized when my daughters were young. They were at home, and they compared themselves to the family members, and they thought that they're at the center of the world. Okay, because we always paid attention to them, and
Yeah.
they thought that they're the smartest. And of course, that changed when on the first day they went to the kindergarten, and they didn't like that day. They had real issues with it because that day did not flatter their ego. They found other kids that may be smarter than they are. And so a lot of my colleagues would prefer to maintain the notion that we are the most intelligent species because they want to be the smartest,
Yeah.
and but again, it's by arguing that we don't have neighbors, that nobody like us existed, that Einstein was the smartest scientist since the Big Bang. By arguing that, it may be a self-fulfilling prophecy, a circular argument. You are not searching, you're not looking. And again, it's just like those philosophers that refuse to look through the telescope of Galileo, saying they know that the sun moves around the Earth. That didn't change the trajectory of the Earth. It just made them ignorant. And we don't remember those philosophers now,
Hmm.
we do remember Galileo because he held the correct view. And in fact, I called the project that I'm leading the Galileo Project because we don't want to repeat that mistake.
Yeah, I find that's the thing with humans though. In every kind of aspect of our being, is ego is such a it's such a big thing. There's so much, like, even if you look at in another aspect, we'll say music. There's so many albums that come out and people are like, this is the worst. All these critics, and then years later they're like, oh no, it's the greatest thing ever. It's like it's just ego, isn't it?
Yeah, because I can tell you that suppose the Galileo Project that actually is now assembling the first telescope system on the roof of the Harvard College Observatory. We're also planning the rendezvous with Oumuamua-like object in the future, and also the
Cool.
expedition to Papua New Guinea for the first interstellar meteor. So imagine that we do find something that is indisputable, like we get evidence that is clear and obvious. What do you think the response of those people that say, oh, that's ridiculous to even search? They would say, oh, there is nothing really new here. In fact, it was discussed for decades. And in fact, we are now doing it. And in fact, we just discovered something even better. And in fact, forget about it.
Hmm.
There is. So that's what they will do. And, I don't really care who tells the truth as long as it's being told.
Yeah.
What I do care about is people refusing to seek the truth because they think they already know the answer. And it's a self-fulfilling prophecy to maintain your ignorance. There are lots of cults who believe in something and
Hmm.
they prevent their cult members from exploring alternatives. That's the way they preserve themselves. We don't want science to be a cult where
Yeah.
people just decide about what's correct and not even seek the evidence. We want it to be diverse in opinions. And people talk a lot about academia, and that's a very important, of utmost importance to maintain diversity in terms of ethnic origin, gender, and so forth, and socio-economic background. It's really important to accept people from all corners of society. But at the same time, it's as important to maintain diversity of opinions
Yeah.
because you never know from where the truth will come. And the only guidance we should use is evidence. But unfortunately, it's not a theme that is practiced. Diversity of opinion is not encouraged. And a lot of people support whatever the herd argues for. And very often societal pressure brings people in academia into the wrong opinion.
Mm.
And just because a lot of people subscribe to that, it maintains its hold. And that is not the way it should be, because academia should be about blue sky, about giving people tenure so that they can explore the road not taken
Hmm.
without worrying about their job security, so that they can be encouraged to think differently. It's all about that, but somehow it's not about that.
Yeah. Yeah. It's definitely more of a modern thing of like, in the past people used to be able to actually have conversations and disagree, but now if you disagree, it's like a weird thing. It's like, no, you have to agree with everything I say, and if you don't, it's like you're not on my side. It's like it's weird. It's
The strange part of that, what really worries me, is that society is split very often on various issues, okay?
yeah.
And some of them have to do with politics, some of them have to do with ethics, but some of them are just because we don't know the right answer, okay?
Mm-hmm. Mm-hmm.
Given that society is split, given that government is not always holding the correct opinion, how can academia be completely united about one view about every topic? That is
True.
impossible. There must be, because the people in academia are supposed to represent society. They're supposed to come from different places, right? And they're supposed to be as split about issues as the society is.
Yeah.
And if you find unanimity, it's completely artificially manufactured by pressure, by peer pressure.
Mm-hmm.
It cannot be real, because obviously society is split. So, I mean, people probably talk differently at their homes than they talk in the corridors of academia, because it's just unnatural for everyone to say the same thing in one environment and to be split 50-50 in other arenas.
Mm-hmm.
And my point is that it would not be bad for academia to be diverse in opinions. We are not supposed to agree on everything.
Yeah.
And we should just agree on the method for finding the truth, which is in science is follow the evidence. And if you don't have evidence, go out and collect it. But don't say that we don't need to collect the evidence because we already know the answer. Because if there are anomalies, things that do not conform to what we already know, if there is a rock that doesn't appear to be a rock. Let me give you an example with respect to Oumuamua. A colleague of mine who is relatively open-minded, okay, he was saying, I'm writing a review paper about interstellar objects, but I call Oumuamua a comet. And I said, why would you call it a comet? It didn't look like a comet. You know, suppose you went to the zoo and you saw an animal and you would call it a zebra, but it doesn't have stripes.
Yeah.
So why would you call it a zebra? And he said, you know, it is a comet because that's what everyone wants to. Most of the objects are expected to be comets that come from other stars. And we just call it for convenience a comet. I said, yeah, but it didn't look like a comet. What is the definition of a comet? That you see a cometary tail. Okay. Obviously, we didn't see a cometary tail. So why would you call it a comet if we didn't see a cometary tail? So he said, well, you know, it's possible that it had a cometary tail when we didn't look. So when we looked at it, the zebra had no stripes.
Yeah.
But your theory is that when you don't look at that animal that has no stripes, it has stripes just when you don't look at it.
Yeah.
Now, does this sound to you like a sound mainstream approach to doing science? I'm asking you. This would appear as the mainstream review article on the subject. And I said, look, that makes, so he made a concession. He said, okay, for you, I will not call it a comet. I will call it an object. I said, you're not making a concession to me. You're making a concession to common sense. If the object did not appear like a comet, you should not call it a comet. And now I'm telling you, this is a conversation I had with a mainstream scientist who is writing a review on this subject.
Wow. That's crazy. That's crazy. Jeez. Man. if it is we'll say of alien origin, judging by how it is, how more advanced are they than us? Or are they not that more, if they could, how more advanced would you say they are than us? Could it be possible that they're even, I'm not going to say not humanoid, but I think humans are going to get to that part where we seem to be going in that direction of AI incorporated humans. But how advanced do you think they would be than us?
Yeah. So we just need to keep in mind that quantum mechanics and relativity are only a century old. That's amazing because all the gadgets that we use that employ quantum mechanics, the cell phones, all the electronics, you know, the conversation that the two of us are having is all mediated by equipment based on quantum mechanics. Okay. And that was discovered just a century ago. So if you think about it, a century is just one part in 100 million of the age of the universe. That's a tiny window of opportunity. So the chance of us finding another technological civilization, which is exactly at the same phase of development, technological development as we are, is quite small. Just because this window existed for us for only a century, okay? Most likely, we will either find them to be very primitive, like we were throughout history, or much more advanced than we are, like in our future. So if they are primitive, we will need to go to those planets out there and find them in the jungles. You know, like those people will not be very sophisticated, just like an advanced species of animals, you know, like we were 10,000 years ago, you know, or 100,000 years ago. But that requires us to go there and land on the planet and start searching the jungles, you know. That's not easy, and it will take a long time because even at the speed of light, it will take us 4 years to reach the nearest star, and most likely, you know, such a thing does not exist in the nearest star. We have to go distant, so it will take us a long time to get there, and it's also a huge effort on our behalf. The other possibility is that they are much more advanced than we are. Okay, they represent our future. And in that case, we don't need to travel because they may be already here. Okay, so if we imagine equipment in our neighborhood, it was most likely produced by a much more advanced civilization than we are. And that, that doesn't, I mean, it means that we cannot easily reverse engineer it. We cannot figure out what it means, what the intent is. Just like a cave dweller going to New York City and seeing all the gadgets, the cave dweller will not be able to reverse engineer those gadgets that, would look very strange and magical to him and or her. But the point is, we could understand that whatever these objects are, they are not natural, they're not rocks, they're not a nitrogen iceberg, a hydrogen iceberg, or a dust bunny. The explanation is given to Oumuamua. And by the way, someone asked me, what would convince you that Oumuamua was not natural? I said, okay, you're saying either it's a dust bunny. So if it's a dust bunny, we take a spacecraft, we pass through it. What's the big deal? We can tell it's a cloud of dust particles that is pushed away by reflecting sunlight. That was a suggestion. I said, that's simple. You just pass through it. It's a cloud. If it's a nitrogen iceberg, we land on it, we see it's nitrogen. The same with a hydrogen iceberg, or we look at the evaporation from it and we use some sophisticated spectroscopy to figure it out. The point is, you can figure it out. I don't understand the origin of this question. It's all based on evidence that I'm seeking,
Yes.
Asking me, how would you find, it's not as if it's a myth. If we had that evidence, I would not be arguing for anything else. Why would I? I would admit that it's a natural object that we've never seen before, okay? But we don't have that evidence. So how can you argue that it's not possible for it to be something else? Because all the suggestions made were of something that we've never seen before. So anyway, coming back to your question, if it is of alien technological origin, it's most likely very sophisticated, and we would not figure it out easily. But we can tell that it's not natural, it's not a bird, it's not a bug, it's not a meteor, a rock, it's not a thunderstorm, because it has bolts and screws on it when we take a high resolution image. Because when we look at it, we see a label that says made on exoplanet Y. These are things we can find, right? It's not a philosophical argument. We just need a high resolution image, okay? And we can monitor the way it behaves and tell that it's not a drone, an airplane, because it moves in crazy ways, if it does it, and it's not a rock. So all of these things are things that, we can validate by taking data with the best instruments we have. So what I'm saying is, we have the instruments to figure out if something is natural, human-made, or something else. Let's just do it. And the Galileo Project, is doing it. We're taking a video of the sky in the infrared, in the visible light, in radio, audio, and in energetic particles. And we will analyze it with artificial intelligence algorithms, figure out what we are seeing. Now, I should explain that no such observatory was constructed. I mean, astronomers in the past built telescopes that look at distant sources, and if something flew above their head, they didn't really pay attention to it, and they were looking at a very narrow field of view usually. So what we are doing is monitoring the entire sky for things that are closer to us. And that was never done before, so it's new territory, it requires innovation. But just over the past weekend, I had a dozen people from the Galileo Project team in my backyard of my home. And we were celebrating the first week where we are assembling the first telescope system on the roof of the Harvard College Observatory. And among those people were our 6 undergraduates from Harvard College and Wellesley College. And they're very excited about it. And when I asked them, what do you think? They have no scars of the stigma that this subject had in the past. They just want to figure out the answer. And, the way that rivers maintain, rivers just have fresh water streaming through them, and that's how they maintain their transparency, and they're still refreshing when you get. And so in much the same way, scientific inquiry should involve people with no scars from the past, no prejudice, no baggage.
Yeah.
And it's really refreshing to see those young scholars being open-minded, doing the best they can to, advance the frontier of knowledge, compared to more senior people for whom I lost hope. Like one of them, after a colloquium at Harvard, came to me and said, Oumuamua is so weird, I wish it never existed. Now, that you would never hear from a
God.
young person.
Yeah.
A young person would never, because a young person would say, wow, it's so intriguing, I would like to find more about it. That's what makes science exciting. So I like to be surrounded by young people, because that's the way to find out new things.
I'd like to think that Oumuamua might be a giant cigar from a place that they make huge cigars, alien cigars.
Well, it could also be a leaflet. Just think about a civilization that sent us a letter saying, this is the recipe for your salvation on a planet that will deteriorate over time. We want to check if our mailbox has any letter addressed to us.
Exactly. Before I let you go, how have you any time, date, release for the book? Or are you still in the early trenches of it?
Oh, well, hopefully in a year from now. But I still have a few more chapters to go through. What I really hope for the coming year is that we will start getting data with the Galileo Project telescopes and with the expedition to Papua New Guinea, and that it would be exciting. We would find things that we don't expect. And when you take the road not taken, there is a chance that you will find low-hanging fruit, because nobody picked it.
Exactly.
And then of course it could be extremely important for humanity as a whole, because we would realize that there is a smarter kid on our block, and it will change the way we perceive ourselves and our plans for the future.
Exactly. Well, thank you so much for doing this. I know we could have probably talked for a long time, but time is not our friend. And I really enjoyed the book. I found it was really interesting, and I really enjoyed reading it. And so,
thank you for the conversation. It's a beginning of a journey, and I hope you will enjoy the future steps of that journey as we find more evidence.
Yeah, it's fascinating. I can't wait to kind of see what happens. I'm sure sometime we'll meet some aliens. Who knows?
Well, my wife tells me that if they ever land in our backyard, she wants me to do two things. One is to leave the car keys with her, and the second is to ask them not to ruin the lawn when they lift off.
Exactly. Or at least mow it. Who knows?
Right. And the question is, why isn't she worried that I will be taken away?
That's another podcast right there. Hey, Avi, thank you so much. I'd love to have you back on sometimes to kind of talk more, because time is time. You know what I mean? But thank you so much. I really enjoyed it.
It will be a pleasure.
Oh, great. Thank you very much, and have a lovely evening.
Bye-bye.
Cheers, brother. Bye-bye.